Did you know that the very same heat that recently set record high temperatures across Europe, shorting out air conditioners, throwing people into chaos, and forcing several European cities to declare an emergency for the first time, could, in the years to come, push Europe into a modern ice age? Yes, it sounds strange. While the whole world is fighting global warming, how could a single continent actually get colder? But not only is it possible, the chances of it are now rising. This is the Atlantic Ocean, which has a direct connection to the Arctic Ocean, where Greenland's ice sheets and the frozen sea of the North Pole are found. On one side of the Atlantic lies the North American continent, and on the other side lies Europe. Both continents share the same ocean, yet, strangely, there is a big difference in their temperatures. For example, take the North American city of New York, which sits at a latitude of 40 degrees north, roughly 4,040 kilometers from the equator and 5,550 km from the North Pole. Its average high temperature in July is 29 degrees. But if we take New York's latitude of 40 degrees and place it in Europe, it lands right over Madrid, Spain, where the average July high is 32 degrees C, 3 degrees hotter than New York. And in winter, while New York drops to about 2 degrees C, Madrid has been recorded no lower than around 4 degrees, a difference of 6 degrees. And it's not just New York. Pick any city on the American continent, match its latitude to Europe, and the European location will feel warmer. For instance, the Canadian city of Calgary sits at 51 degrees north, which lines up with Frankfurt, Germany. Yet in December, Calgary recorded 12 degrees C, while Frankfurt in the same month was around 8 degrees, a difference of 20 degrees. Try it yourself. Take any American city, check its latitude on Google Earth, then look at the temperature of the European city at that same latitude, and you'll find the European one is warmer. The main reason Europe is warmer than the American continent is the Atlantic's system of ocean currents. This system is called the Atlantic Meridional Overturning Circulation, or AMOC for short. It's a natural system that carries heat from one place to another through ocean currents. AMOC is actually part of a much larger global ocean circulation that moves warmth around the entire planet. But since our goal is simply to understand why Europe is warm, we'll focus only on the Atlantic portion. AMOC works like a conveyor belt. It lifts seawater near Greenland and carries it far south, all the way down toward Antarctica, and then brings that water back up past Mexico, along Europe, and back to Greenland. But during all this, why is it only Europe that gets warmed? The most important event that drives the cycle, the one that gives AMOC its life, happens in the ocean depths near Greenland. Near Greenland, when the surface water cools, cold winds cause a great deal of water to evaporate, and sea ice begins to form. When seawater freezes into ice, the ice doesn't take the salt with it. All that salt is left behind in the remaining water. In science, this process is called brine rejection. So between evaporation, leaving salt behind, and the newly formed ice rejecting salt, the seawater near Greenland becomes extremely salty and cold. Because of the high salt content, this water becomes denser and colder. The salt also lowers the water's freezing point, which is why the water here stays liquid even at 2 degrees. There's a rule in science: cold, dense water always sinks. And that's exactly what happens here. Near Greenland, this water begins sinking into the ocean depths. Being heavier, it travels thousands of meters down along the ocean floor toward the south, reaching the South Atlantic near Antarctica. When this water reaches the Southern Ocean around Antarctica, powerful westerly winds push the surface water away, and through upwelling, the salty water from thousands of meters below rises to fill the gap. This water then slowly moves along the surface toward the northwest, toward the Gulf of Mexico. There it warms up again and merges with the Gulf Stream. The Gulf Stream refers to the strong currents and winds that flow from Mexico toward Europe. These carry the warm surface water past Europe and back up into the North Atlantic. During this journey, that warm water plays the single most important role in warming the climate of Britain, Ireland. Along the way, this warm surface water keeps gathering more salt through evaporation and from the salty water entering from the Mediterranean Sea. And as soon as this water reaches the Arctic again, it cools once more and begins to sink. That's where one cycle of AMOC completes and the whole process starts over. This entire system is often called a global conveyor belt, one that delivers warmth to Europe and cold to Antarctica. But here's the question. If the world's average temperature is rising because of global warming, how could Europe be the one continent that ends up facing a kind of ice age? Consider that a single loop of AMOC takes hundreds or even thousands of years to complete. Without a system like this, Europe would naturally be just as cold as the Canadian regions at the same latitude, places like Labrador or Newfoundland. And unfortunately, that is exactly the future we may be heading toward. Yes, many in the scientific community believe that climate change could cause AMOC to collapse. If that happens, Europe might become the only part of the world to actually grow colder during a period of climate change, and so cold that a modern ice age could begin there. So how could a system this ancient come to an end? Is it even possible? The bad news is that the world is moving in exactly the direction that could lead to AMOC's collapse. Here's how. Because of global warming, the world keeps getting hotter, Greenland's ice sheets are steadily melting, and this is increasing the amount of fresh water in the ocean. In that ocean, where salt levels are usually high, this fresh water is pushing the salt levels down. On one hand, melting glaciers are lowering the salt levels. On the other, rising temperatures mean less sea ice is forming. And less sea ice means even lower salt levels because, as I explained earlier, when ice forms on salty seawater, brine rejection separates the salt out. When less ice forms, that salt simply mixes back into the wider ocean. The end result of all this is that the water around Greenland becomes less salty and warmer, meaning its density is slowly dropping. And if this low-density water no longer sinks to the ocean floor, then the single most important condition fueling AMOC will no longer be met, and this ocean current will stop flowing from the Arctic to Antarctica altogether. In simple terms, the faster Greenland's ice sheets melt, the faster AMOC will end. Scientists fear that if this system merely slows down, nothing may be able to stop it, not even if we cut greenhouse gases or stop burning fossil fuels. That's because one full AMOC cycle takes several thousand years to complete. If it shuts down, restarting it would take at least as long as it took to stop. Climate and ocean scientists have been warning for decades about the possibility of AMOC weakening or collapsing. But earlier, there was no solid data to back these warnings. They were just estimates, so no one took them seriously. Now, however, researchers have built a complex system to monitor AMOC in real time. Part of this system is known as the Rapid Array, launched in 2004 by the UK's Natural Environment Research Council. It relies on thousands of sensors placed beneath the Atlantic, stretching from the Bahamas to the Canary Islands. These sensors, thousands of meters deep, measure the water's flow, temperature, pressure, and density. Since 2004, this system has continuously monitored AMOC, and the data it's giving us is not just surprising, but deeply alarming. The flow of AMOC beneath the Atlantic is measured in units called sverdrups. One sverdrup equals 1,000,000 cubic meters per second. In other words, 1 billion liters of water every second. When AMOC's flow was first measured in 2004, it was roughly 18 to 19 sverdrups, around 18 to 19 billion liters of water. But today, AMOC's flow has dropped to about 15 to 17 sverdrups, meaning that in 20 years, its flow has decreased by around 16%. And this decline didn't happen overnight. Looking at the year-by-year values, AMOC's flow has been continuously dropping, a clear downward trend. A 2025 geophysical research paper reported that AMOC's flow is declining at a rate of about 1 sverdrup per decade, and that if it falls to around 6 sverdrups, it will enter a shutdown phase. The biggest question here is whether AMOC's slowdown is being caused by global warming, by US humans, or whether it's the result of a natural fluctuation. This is a question researchers still can't answer, because to know for sure, we'd need at least 29 years of data, and so far we only have about 22 years. It won't be until around 2033 that we'll know whether AMOC is weakening because of its own natural cycle, or whether we humans have a hand in it too. The chances are that AMOC's flow is declining naturally, because we know that something very similar happened 12,000 years ago, when there was no concept of fossil fuels at all. 12,000 years ago, as the last ice age was ending, the ice sheets covering North America and Europe began to melt. This melting poured enormous amounts of fresh water into the Atlantic, which lowered the salt content there. With less salt, the water became lighter and the AMOC cycle broke. When that cycle broke, Mexico's warmth could no longer reach Europe, and during this period, Europe's average temperature fell by 5 to 10 degrees. Scientists learned about this through paleoclimatology, using ice core samples, ocean floor samples, and deep soil samples that reveal a great deal about the atmosphere of thousands of years ago. This period in Earth's history is known as the Younger Dryas. Dryas is actually a genus of flower found only in the Arctic Circle. Yet in 10,000-year-old European soil samples, pollen from the Dryas flower was found everywhere, supporting the idea that this region was going through severe cold because AMA had broken down. It's after this flower that the period is called the Younger Dryas. In Europe, this era lasted roughly 1,000 years, after which AMOC restarted and brought warm temperatures back to Europe. Is that era about to return? For now, different scientific studies hold different views on this. But the warnings we're receiving right now suggest AMOC is entering a shutdown phase once again. Beyond the rapid array, consider a thermal image of our Earth. While the rest of the globe is warming, there's a white blob showing near Greenland. That white blob indicates that the seawater there is cooling. This region is the only part of all the world's oceans that is actually cooling during a period of rising global warming. A sign that Greenland, and if that's the case, this fresh water must be reducing the ocean's salt. The presence of this cold blob near Greenland further supports the idea that AMOC's cycle is heading toward collapse. So the question becomes, if all of this comes true, and AMOC really does shut down, what would change in Europe? What would that modern ice age look like? Cities like London and Dublin, which enjoy mild weather today, would routinely see temperatures drop to somewhere 15 to 20 degrees. On top of that, growing crops in Northern Europe would become nearly impossible. Europe's ports, which stay open 365 days a year, would freeze over in winter. The same Europe whose people struggle in summer without air conditioning would come to crave warm air. Demand for heating gas would rise so sharply that Europe's entire energy grid could collapse. And all of these problems together would trigger the largest migration in history. Imagine it. The very people who once gave refuge to migrants from other countries, now becoming climate refugees themselves, migrating towards Spain. And it won't be Europe alone that suffers AMOC's collapse. The rest of the world will bear the consequences too. Continents like South America and Africa, along with the South Atlantic, would be scorching because the heat that used to be carried away would now stay trapped there. The world always assumed that global warming simply means rising heat. But nature's balance is so delicate that too much heat could actually push Europe toward another ice age. Whether it happens in 2050, in 2100, or even later, one thing is certain: Greenland's melting ice and this invisible conveyor belt flowing through the Atlantic are giving us a warning. One that, if we fail to understand it in time, could leave the greatest climate disaster in history waiting for us. If you find this video informative, subscribe to our channel for more information and news analysis. Thank you.